Hey all, welcome to the second 9.5 video. This is to supplement Mr. Maconie's video and just to clarify a few things that I think will be useful for you. So I've made up 3 other examples that I think would help with the exit slip today. So if we take a look at this function, the first thing I want to focus on is if this function either has a horizontal or a slant asymptote. It can't have both of these at the same time, so we need to determine which one it is based on the end behavior, what's happening. So when you're looking at a function, before you factor or do anything else, what I would always focus on is what the powers are doing. So in this case, we have an x on the top and an x squared on the bottom. So if you think about end behavior, this would be considered bottom heavy because the exponent of the denominator is larger than the exponent of the numerator. And whenever you have something that's bottom heavy, that leads to having a horizontal asymptote, and that leads to be, if you're taking a big number and dividing it by an even bigger number, you are approaching the number of 0. Because think about it, if you took 100 and divided that by 100 squared, which is about 10,000. If you do 100 divided by 10,000, that's going to be 0.01, which is really close to 0. Okay? So that means if we have a horizontal asymptote, that means that this function automatically does not have a slant asymptote. The horizontal asymptote would be y equals 0. The reason it's y equals is horizontal. Always looks like this. If you think about a coordinate plane, this is crossing the y-axis at a particular point. So whenever you have something that's bottom heavy, you're always approaching 0, and your horizontal asymptote will always be y equals 0. Okay? Now the second part, I ask you what the vertical asymptote is, and this was not necessarily in Mr. Maconie's video. So if you would like to find the vertical asymptote, what we need to do is factor at this point. So the numerator of this does not factor, it's not x squared, but the denominator factors to be x plus 2, x minus 2. And like Mr. Maconie's video, nothing crosses out here, so we do not have any holes. However, these two values in the denominator we cannot equal. X cannot be negative 2 from the first piece and positive 2 from the first piece, or excuse me, from the second piece, because these two values cause your denominator to be 0. So that means that this function has 2 vertical asymptotes because there's 2 values you cannot cross. So the vertical asymptotes would be x equals negative 2 and x equals positive 2. The next example, if we're thinking about if this is top heavy, bottom heavy, or neither, we want to take a look at the highest exponents we can see here. So notice, it's tempting to think that this again is bottom heavy because you have a smaller exponent on the bottom than the top. But what you need to look at is that this is the largest exponent on the top and this is the largest exponent on the bottom. So you're really comparing 5x cubed over 4x cubed. And the reason this lesson is called end behavior is you're really only looking at the highest exponent on top and bottom because that determines generally what your function looks like, so you can, really find out what's going on here. So these, this time, both the exponents are the same power, which means that top heavy, bottom heavy, or even, these are even. And when you would like to find what the asymptote is when they're even, is you really only look at the leading coefficients, because picture, again, you're plugging in a really big number, or plugging in a number for x cubed. If it's x cubed on the top and x cubed on the bottom, the x cubes in a way really just cross out. So you're just left with the leading coefficients of 5/4. So in this case, whenever you have an even, you also have a horizontal asymptote. So in this case, the horizontal asymptote will be y equals 5/4. So that means on a graph, 5/4 is 1.25. You'd have a horizontal asymptote here on your graph. That means automatically that there is no slant asymptote, because if there's a horizontal, that means there cannot be a slant. If you would like the vertical asymptotes, if you'd like to find these, what you need to do again is factor and look. So in the numerator, what we could do is if you look at the original function in green, you could take out an x squared, and if you did that, you'd be left with 2 plus 5x. And in the denominator, if you factored, you could take an x out, and then you'd be left with 4x squared minus 25. So at this point, there's nothing else you can do in the numerator, so I'm going to rewrite that. But your denominator, this piece, you can keep factoring. Both 4 and 25 are perfect squares. So that would be 2x plus 5, and then 2x minus 5. Now, it looks like we can cross these two out, but unfortunately, they're not the same, because this is 5x and this is 2x. So what we would do is we would look at your denominator and decide what values would cause your denominator to be 0, and those would be your vertical asymptotes. So this time we actually have 3 vertical asymptotes. X cannot be 0, so we have a vertical asymptote at x equals 0 from this piece. From the second piece, we have a vertical asymptote at negative 5/2, and we have a vertical asymptote from the third piece at positive 5/2. So it's okay to have 3 vertical asymptotes. That does happen sometimes. The third example, if we're asking top heavy, bottom heavy, or even, or talking about the end behavior, you again are only going to look at the highest powers that you see, top and bottom, which would be x cubed over x squared. Now, because this time this is a top heavy function, this is the only circumstance where you end up getting a slant asymptote. So top heavy is the only one that gives you slant, which means automatically I do not have any horizontal asymptotes this time. Now, how do I find a slant asymptote? We have to do some kind of division. Unfortunately, in this example, we're dividing by x squared minus 1. And as you may recall, we can only do synthetic division if this power is linear or this power is 1. So we have to do long division, but I don't think it's a bad thing because it's good to see a little review here. So I'm going to write my functions in here. A reminder that'll help you on your exit slip. If you are missing any of these terms, if this went from 3x squared to just 2, you'd have to put in a placeholder of 0, so please remember that. So if you're doing long division here, x cubed divided by x squared is just x. I'm going to put that over its like term. I'm going to multiply these back. X times x squared is x cubed. X times negative 1 is negative 1x. I am now going to change the signs on both of these. Cancel this out. And I'm going to bring down the negative 3x squared, combine these and get plus 3x. Then I'm going to do division again. Negative 3x squared divided by x squared is negative 3. Multiply that back in. That would be negative 3x squared. Negative 3 times negative 1 is a positive 3. We don't really have a like term, so I'm really assuming there's a 0 there. I'm going to again change my signs. I'm going to make this into a plus, make this into a minus, carry down 3x minus 3. I can't divide x squared out of 3x, so that means that this piece is my remainder. But as Mr. Marconi said, the remainder doesn't matter for your answer to the slant asymptote. The only thing that matters is what's left with up here, the part that worked. So your slant asymptote here would be y equals x minus 3. Okay, and so when you're doing long division, the remainders never matter when you're finding a slant asymptote. Okay. The vertical asymptote is again found by factoring. So if you would like to find your answers to the vertical, you need to factor the original function. So in the numerator, we would take an x out, and then you'd be left with x squared minus 3x plus 2. And on your denominator, you could factor that to be x plus 1, x minus 1. If I kept factoring the top, because we have the highest power of x squared, that'd be x minus 2, x minus 1 over x plus 1, x minus 1. So this time, we do have something that crosses out. We have the x minus 1s that cross out, which means this would be a whole if I asked for it, but I didn't. And so your vertical asymptote is whatever is left in your denominator. So it's just this piece, which means that x cannot be negative 1. So your vertical asymptote is just 1 this time, x equals negative 1. And the other piece is a whole. Okay. Last thing to clarify, let's say I give you a function f of x equals x cubed minus 4x squared plus 1, and I give you, let's make it negative, and I give you g of x equals negative x to the 4th plus 2x squared. I want to remind you about something from earlier in the semester. If you see this first piece and you're saying it's a cubic that's negative, remember that really looks like this as a general parent function. And if you see negative x to the 4th, that really means it's like an upside down u, because it's more parabola-like and it's facing downwards. So if I asked you what the limits were on these, I would really suggest you drawing a picture first and then looking to see what happens. So if I asked you what is the limit as x is approaching infinity of this function, as x is going towards infinity, the y value is going down. So this answer would be negative infinity. And if I asked you the limit as x is approaching negative infinity, that means as you're going to the right, the graph is going upwards. So that means that the answer to this would be positive infinity. This logic will help you on your exit slip and for future things. My suggestion is whenever you're in doubt, graph it and look at it. So in this case, it's a cubic, so I knew it was a snake. A negative, I knew it was decreasing. Then as I looked at my limits, as x is going to infinity, I looked to the right. As x is going to negative infinity, I looked to the left. Okay? So I hope that these extra examples were helpful. It's always good to hear a lesson from two different perspectives. So I hope Mr. Bocconi's video was helpful. I hope this was helpful. So feel free to try the exit slip at this point, and you can come and even see me in a Google Meet for extra help. Thank you.